Hey, good morning, everybody. Here we are with Distance Learning Week 1. I trust you found this information under Notes and Assignments. Remember, I try to keep making sure we have our Blackboard Collaborate link, along with the link to all the materials that we talked about during our first session. If you are in my second period, maybe you're doing this before we get together, you can peek at what's to come. Okay, so for this first week, we're just going to dial it back a little bit and take a look at each of these function families that we talked about. And I'm asking you to write a parent function for each graph. So right away, we want to start with our linear. This is our linear conversation. Whenever we have a graph that has a slope or a constant rate of change, we know it's linear. When we talk about our linear graphs, our parent function is of course positive, but we can have a negative slope, and we can have this graph move up and down according to wherever our y-intercept is. Our next conversation, at the end of Algebra 1, you started to explore our quadratic graphs, and our quadratic graphs happen because we square x. So as soon as we square x, two things happen. You get this nice curve because it's moving up at an exponential rate instead of the constant rate of change that happens with the slope. And all of these negative values that you get with a linear equation are no longer negative because they've been squared away. So that's why this whole conversation that was down here on the negative side is now going to have a positive outcome when we talk about that output, that function of that x. All right, our next graph that we all love to love is going to be our absolute value. And when we're looking at an absolute value graph, we're talking about recognizing that I don't care if the output is positive or negative. All I care about is how far is it from 0. So here, positive sides do have a slope. There is definitely a slope of my positive or my negative side because it is a constant rate of change. It has a linear side. But instead of these outputs being negative, all I care about with these negative inputs is how far it is from 0. So we can match up and talk about those parent functions in that sense. All right, next up, when we're taking a look at our function families, what is it that gives us this curve that happens as it goes up, but try this pen. This curve as it goes up, but ends up giving me a negative output. So because this is a curved conversation, I know that x is going to be to an increased power, but having that odd exponent is what allows us to have these negative outputs. And of course, you can see this curve is a lot tighter. I'm getting higher faster. This is our cubic function. When we talk about if we have an odd input value, it's going to give us an odd output or an odd output value as a result. Okay, so when we looked at each of these graphs, we ended up talking about all these different features of the graph, and these vocabulary words should come back at you in a way that makes sense to you. Okay, so when we talk about our domain values, I'm talking about all the possible input values. So I'm reminding myself that this is everything that could possibly go into the function. When I'm looking at something like this function, it has an absolute stop and an absolute boundary on each side. which means all of my x values are existing within this range. So when I want to express it, I'm going to use my interval notation. Because this is a closed dot and because this is a closed dot, I'm going to be able to use my box. And I'm looking only at my x values. Where does it start and where does it stop? And remember, you're going from least to greatest in that value. All the possible input values is our set of our domain. Okay, so when we look about range, we're talking about, hey, what is the set of all the possible output values? What can come out of this function? So we're going to talk about what is the highest it can go and what is the lowest that it can go. And you can see that this is a closed dot and this is a closed dot, so that's why I'm back to having my closed boxes. And here I'm going to care about my output values. What is the absolute lowest and what is the absolute highest that each of those values could have been on this graph. Alright, so when I'm doing a graph, I want to talk about a vertical line test. And the vertical line test is going to test to see that it's a function. So what I'm going to do is I'm going to take my pencil and I'm going to slide it across, and I'm going to see if there's ever a time that the pencil hits the graph twice at a time. So because it passes the vertical line test, that means that therefore, yes, it is a function. When we talk about the horizontal line test, our horizontal line test takes us back to, is it a one-to-one conversation? So when I take my horizontal line and I look at, does it ever, and look, yes, it does hit this graph here and down here twice. So does it pass the horizontal line test? No, it doesn't, which means it's not one-to-one. This means that when I have different input values, I get the same output values. And you can see that right here in our maximum point. Because two different inputs can give me the same output, it's still a function, but no, it's not one-to-one. So when we talk about vertical line tests, we're talking about, is there a repeat in the domain? Talking about the horizontal line test, what we're talking about, is there a repeat in the range of a function? This is our domain. So if there's no repeat in the range, that means that every single input has its own output. Okay. When we talk about increasing and decreasing behavior, it's a conversation of, as x is getting bigger, as x is getting bigger, what is happening to y? If y is getting bigger, it's increasing. If y is getting smaller, it's going to be decreasing. So we talk about our x values as we move from left to right. As this x moves, where is the graph getting smaller? And you can think about it like a roller coaster ride. See how I'm going down, 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 down? See how I start going up, 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 up? So from this point to this point, my roller coaster ride, my x is getting bigger and my y are getting bigger. Here nothing's happening, and here I'm falling. So if I wanted to say at what points my roller coaster was going up, I would say that from -4 up to 0, my x is increasing. And remember, it's a conversation of x. It's the story of x as it goes left to right. As x is getting bigger, what is happening to y? When we talk about where is it decreasing, if I wanted to look at decreasing, I'm looking at x getting smaller here. I'm looking at x, or my output getting smaller. So while I'm looking at how my input is increasing, I want to look at where is that output getting smaller. And we'll do that again in a different color pen. See how it's getting smaller? See how it's getting smaller. So when we're talking about decreasing, I want to say that from -6 to -4, it's getting smaller. And it's also happening over here. And remember, we care about the x values from 3 to 6. So a couple different notes about this increasing and decreasing. You're moving left to right, and you're always making sure that you're using parentheses, because that change, that fall, or that increase doesn't happen until you leave that point. So it's not going to be a box. It's only going to be a curve. So then we have our last final consideration, and that is, where is it constant? Where is this constant? And see how there's no change here? Because there's no change, we wind up recognizing that from the x value of 0 to +3, there's no change, because this is a constant or a flat line. This has a slope of equal to 0. Your slope is equal to 0 there. So this ends up being some of the hardest conversations for kids, recognizing the increasing and decreasing and being constant. And we want to know, as x is getting bigger, what is happening to y, which is why we talk about x from a left to right situation. From here to here is where it's increasing. From here to here is where it's decreasing. And this is where it's constant. All right. Our last considerations are our x and y intercepts. So what we want to know with our x and y intercepts, and remember, these are coordinate points. These are x, y coordinate points. So we're talking about our y-intercept is always going to be the value when x is equal to 0. When x is equal to 0, our output is 1, 2, 3, 4. You want to make sure that that's a 4. Our x-intercepts is where it hits our x-axis. So that means we have an output of 0. So here at -2, we have an output of 0. And then at -6, we have an output of 0. So our intercepts, make sure you pay attention to where the 0 is. All right, let's flip over and take a look at the back. When we look at the back, we have another graph that we can take a look at with our conversations. The difference between this graph is, check it out. I have arrows as endpoints, which means it goes on forever and ever. So go ahead and pause the video, and then you go ahead and answer these questions and check back in. All right, let's see how we did. So what those arrows mean is that the domain and the range continue on forever and ever in each direction. So by having these arrows, that means that I'm going to have possible x values forever and ever in a negative and in a positive sense. The same with my output values. My y's are going to continue on forever and ever in a positive and forever in a negative sense. So I show that by using my interval notation, recognizing that everything from negative infinity to positive infinity could be a possible outcome. When we talk about my vertical line test, does it pass it? Yes, it is a function. There are no repeats in the domain. meaning that that every input gives me a unique output. I don't have any repeats in output values. When I test my 1-to-1, no, it doesn't pass my horizontal test, because what ends up happening is I have a repeat in my range values. So when I look at output values, these two inputs give me the same answer. So it's like if somebody shows up wearing the same outfit as you, two different people can wear the same outfit. So that's definitely possible. Okay, when we talk about our x-intercepts, what is across the x-axis? 2. And remember, these are coordinate points. So it's interesting. You need to make sure you know what you're talking about. When you're using interval notation versus coordinate points, they can look the same. So this graph introduces us to a conversation of relative minimums and maximums. Because this graph continues on in both directions forever and ever, I can have a conversation about, okay, but where does it, where are my local minimums, my local maximums? Where does the graph change direction? This is a local minimum because everything on either side of it is higher than it. It's like a little valley. If I come up to a hill here, this is my local maximum because both points on either side of it are lower or beneath it. So I have 2 local maximums and 2 local minimums, and I can list them as such. This graph has us talking about our end behavior. So when I'm looking at my end behavior, I'm asking, where is it going? Where is this graph headed? And as x approaches negative infinity, this graph is going off forever in that direction. As x approaches positive infinity, this graph is falling forever and ever. Okay. Our last review topic is when we start talking about transformations of graphs. And when we're looking at transformations of graphs, we want to pay attention to this big idea here, this formula here. Because in all of our different family functions, and you can see I have some linear, some quadratic, a cubic, and an absolute value function, we can talk about moving it all over the coordinate plane. So here we go. When I look at this first value, that's going to tell me, am I upside down? Am I reflected? Is there a reflection going on? And that's what this negative value will tell you about. When I look at this A, and cross my little arrows here, this tells me whether I have a stretch or whether I have a compression. So that's going to tell me whether the graph is real tall and skinny or whether it's open real wide. So your stretch, your greater than 1 values are going to make your graph get faster, faster, or higher, faster. And then anytime I have a fraction here, that means it's going to be a compression. Okay, so then we have our H and K values. So this H value is what tells me, am I moving left or right? And remember, it's going to be opposite sign. Is a naturally negative conversation. Our K values are going to move us up and down, and that is going to be true to sign. So when we look at each graph, and it doesn't matter what power it is or whether it's an absolute value, my A and my H and my K tell a story of where the graph is on the coordinate plane. All right, so when we look at our exercise here, it says identify the parent function, transformations, and then do a brief sketch of the graph. So I'm going to get myself set up for success here. So first of all, I'm going to recognize this one is linear. I'm going to go, this one is quadratic. This one is quadratic. This one is cubic. And this is an absolute value. And here I have another quadratic. All right, so let's take a look at what's going on for each one. So I'm going to give myself a coordinate plane to sketch for each graph. And I want to make sure that I leave myself enough room to sketch for each one. Now don't forget, you have your graphing calculator and you have Desmos. So anytime you're not sure of what a graph is going to look like, you are absolutely 100% encouraged to graph it. Take a look at the picture. Sometimes if you're a visual learner, it's easier for you to understand things if you check out a picture first. All right, ready? This graph I know is going to be, first of all, a reflection. It is going to be a stretch by 5. It's going to go up 5 times faster. And my vertical shift is going to have it coming down 7. So if I were to count 1, 2, 3, 4, 5, 6, 7, this graph is going to be a pretty steep one that's linear and a negative slope. All right, let's talk about this one. I know it's quadratic. I know I have a stretch by 3. It's not going left or right. This graph is going down 5. So if I were to count 1, 2, 3, 4, 5, this graph is going to sit right there. It's not moving left to right. It is positive, but it's going to be a pretty skinny positive graph because of that stretch by 3. All right, so you take a look at these next 4 and see if you can predict how these graphs will look. All right, let's see how you did. I have a compression by 1/2, and remember that's naturally negative, which means I'm going to be moving to the left. If I see a positive, that means there was a negative movement, so that means I'm going to go to the left too. So that compression is going to make it open wider, and it's going to move it 2 to the left. All right, my cubic graph here, the only thing that's happening to it is it's going up 4. So that was the easy one to draw. Here I have a naturally negative situation, which means it moved to the right 4. Here's my absolute value. So this one was a biggie. It had everything involved. This one had a reflection because it was negative, a stretch by 2, which means it was going to be skinnier. It moved to the right 3 because that was positive. And we had a little mess up here. I went up 6. So if I look here, I went over to the right 3 and up 6. This is going to be where my vertex is. And I was going to reflect and stretch. So it's a skinnier upside down graph. Okay, so here's what I want you to do. I want you to go to student.desmos.com, and this is your exit ticket for this lesson. So here's your 10-point exit ticket. I want you to go to student.desmos.com, and I want you to type in SCR MB4, and it's pretty cool. It talks about these transformations of graphs and how we move them all around. In addition, you're going to have your 10-point e-cart, and we're going to have that about our function families, domain and range, all these fun considerations. So show up to class, do your exit ticket, do your e-cart, and you're looking at an easy 25 points for this week. All right, you guys, take care, stay safe.